Hey everyone, this is Mr. Petrosino, and this is the fourth lesson on the laws of exponents. This will be your last video on any new material on the exponents unit. Today's focus is going to be on something called the power rule. So the objective is to evaluate and or simplify expressions by applying the power rule. So if you look at the warm-up, it says, use the model to the left to simplify the expression on the right. So if you notice on the left-hand side, I have x to the second power to the third power. So I have two exponents here. Well, since the x and the exponent of 2 are inside parentheses, that represents our base. So how many times am I multiplying x to the second power? 3 times. So x squared times x squared times x squared. Well, the product rule from lesson number 2 tells us that when we multiply values with the same base, we add the exponent. So 2 plus 2 plus 2 is 6. So if I follow the same steps on the right, w to the fourth power to the second power, that means I'm multiplying w to the fourth power times w to the fourth power. Well, I'm going to add my exponents together. So 4 plus 4, and 4 plus 4 equals w to the 8th power. Now, writing it in expanded form like we did here, w to the fourth or w to the fourth, or on the left-hand side, x squared times x squared times x squared, can be a little bit time-consuming. So what we're focused on today is going to be figuring out the shortcut. So what relationship do the exponents inside and outside of parentheses have with the exponent in your answer? So let's look at our exponents. On the left-hand side, we had a 2 and a 3, and it resulted in a 6. On the right-hand side, we had a 4 and a 2, and it resulted in an 8. So what relationship do you see between 2, 3, and 6 and 4, 2, and 8? Well, what I see is that if you multiply the exponents inside and outside, and outside parentheses, you get the same answer. Right, so for the first one, x squared to the third, well, if I multiply 2 times 3, right, 2 times 3, I would get 6. Or for letter B, if I multiply the 4 and the 2, 4 times 2, would give me 8, same answer. The reason that works is because multiplication just represents repeated addition, right? 3 times 2, or 2 times 3 means 3 groups of 2. 4 to the second power means 2 groups of 4. So we call this the power of a power. When you raise a power to, to another power, we multiply the exponents. So let me pull up the page. So for example, 8 to the fourth power to the third power. Instead of expanding it out, since I have a power raised to a power, or an exponent raised to an exponent, I'm going to multiply the 4 and 3 together to get 12. Or k to the fifth power to the seventh power, I'm going to multiply the 5 and the 7 to get 35. So this is just another helpful rule to remember. If you need to expand it out to make it make a little more sense of it, you're welcome to do so, but this is somewhat of a shortcut. So 7 squared to the 6th power. Write each expression as a single exponent and by using or applying the laws of exponents. So instead of expanding it out, since I'm raising a power to a power, right, so I have an exponent inside parentheses and an exponent outside parentheses, I'm just going to multiply that 2 and 6. 2 times 6 gives me 12. Notice it does not say evaluate, so I don't have to plug that into my calculator. For number 2, I have 1.3 to the fourth power to the 9th power. So a power to a power. I'm going to multiply the 4 and the 9. Notice how the base right now is staying the same. 4 times 9 is 36. As I mentioned in previous lessons, for positive bases, you don't necessarily need parentheses in your final answer as a single exponent, but if you want to, you're welcome to put the 1.3 in parentheses. You're welcome to put the 7 in parentheses. When you're dealing with fractions and negative values, you must use parentheses. So just in general, for any integer x, where m and n are positive, so as long as these exponents are positive, we just multiply the exponents together. So that's just representing the rule algebraically. So now for the think, pair, share. Obviously, we can't pair up because we're most likely doing this individually, but I'd like you to think about this scenario. Something is incorrect about the equation below. Work with a partner to identify and explain the mistake. So obviously, I did not revise this worksheet that I was going to give you because you are not working with a partner. But, you know, it is the digital world. You can always communicate with other people about this lesson. So what is different about the left side and the right side? Because it's saying it's incorrect. Something is done incorrectly. Well, from what we just discussed, I did multiply 3 times 4 to get 12. So the exponent must be correct. There's something wrong about the base. Well, if I expanded this out, I would get 2p to the third power times 2p to the third power times 2p to the third power times 2p to the third power. All right, I'm taking my base inside parentheses and I'm multiplying it 1, 2, 3, 4 times. Well, now I'm going to multiply what we call the coefficients. The coefficients are the 2's. So what is 2 times 2 times 2 times 2? That would be 16. And my exponents, remember, repeated multiplication here. Repeated addition. So if I add my exponents, 3 plus 3 plus 3 plus 3, I would get 12. So again, my exponent is correct, but my base is incorrect. Why is this incorrect, or what did a possible student do? They forgot to raise the 2 to the fourth power. Because the 2 is in parentheses, it is also being raised to the fourth power. So if I were to really show this in 2 steps, this really means 2 to the fourth power times p to the third power times 4. Because even though we don't see it, there's really a 1 as an exponent for that 2. Excuse me, it got cut off. There's really a 1 as the exponent for the base of 2. So 1 times 4 would also give me 4. Okay, it's a little bit tricky, so we're going to continue this on the next page. I tried zooming in a little bit more on this video because I know some students have had a little bit of trouble seeing it specifically on their phones. Again, I'm going to recommend full screen so that you can see it as clearly as possible. So taking what we just did on the last think, pair, share, I want to give you, I guess, the definition or the explanation behind your last rule. So we just did power of a power. Now this is called power of a product. It's just a little bit different. The main difference is that we're going to have a coefficient in front of our variable. So to find the power of a product, find the power of each factor and multiply. So again, here, the only difference is that not only do I have p to the third power, but I have a 4. So the 4 is being raised to the fourth power, and the p to the third is being raised to the fourth power. Both terms inside. Here, it's even longer. Not only is the n and the m being raised to the fifth power, but so is the negative 2. So let's do an example. 11 times 4 to the 9th power. If I wanted to find the product of a product rule, well, the 11 is being raised to the 9th power, and so is the 4. Okay, I'm not asked to evaluate, I'm just simplifying. Or here, not only is the x being raised to the 7th power, but so is the 5. So 5 to the 7th power times x to the 7th power. A common mistake is forgetting about the coefficient in front. So whether you are having 2 variables being multiplied or 2 variables being divided, so long as they are in parentheses, they are both being raised to the power. If you feel comfortable, you can try these next few on your own. Otherwise, you're welcome to follow along with me. This is most likely the trickiest of all the rules, so it does take some practice. If at the end of this lesson you're still feeling a little bit confused, I am more than happy to explain in more detail. So exercise number 1, write each expression using a single exponent. So again, you are not evaluating, we're just writing this as a single exponent. Well, here I just have a base of 15, so this is a power of a power. What I'm going to do is I'm going to take the 3 and I'm going to multiply the 9. 3 times 9 would give me 27. So 15 to the 27th power. Exercise 2, same thing. I just have a base of s. So I'm going to multiply my exponents. 17 times 4. 17 times 4 would be 68. Here's where, for exercise 3, I have a power of a product. Okay, think of the word product means the answer to a multiplication statement. I'm multiplying 3 squared and a to the 4th. So both are being raised to the 5th power. So what is 2 times 5? And then what is 4 times 5? Okay, notice how I'm taking both factors and I'm raising it, both powers, and I'm raising it to the 5th power. So 2 times 5 would be 10 times 4 times 5, which is 20. You do not need that multiplication sign in the answer if you don't want, but you're welcome to do so. Here we have a fraction in parentheses. Okay, so not only is the 12 being raised to the 2nd power, but so is the 7. So if you wanted to write this out, 12 to the 2nd power over 7 to the 2nd power. Looking at exercise 5, we have 3 things being raised to the 7th power, the 5, the x, and the y squared. So 5 to the 7th power times x to the 7th power. And then for the y, there's a 2 there, so 2 times 7. What is 2 times 7? It is 14. The power of a product rule, you're really just taking it one step at a time. If you isolate each base, it's not too much different than what we did in the previous lessons. Looking at exercise 6. If this is a good time to stop and try it on your own before you watch me do it, but again, I can't stop you if you want to keep watching. A squared to the 4th power. So we do 2 times 4. B to the 4th power, right? Even though we don't see it, there's a 1 there. So 1 times 4. And c to the 3rd power to the 4th power. We multiply those exponents. So 3 times 4. If you want to put the 1 times 4 there, you can. All right, but the identity rule, anything times 1 remains itself. Let's just simplify that. So we have a to the 8th times b to the 4th times c to the 12th. Two more, exercise 7. Okay, we have a fraction inside parentheses. Both the numerator and the denominator are being raised to the 4th power. So we multiply 2 times 4. And we multiply, in this case, 3 times 4. Okay, if those parentheses weren't there, only the numerator would be raised to the 4th power. And last one, another fraction, 5x to the 3rd power over y to the 3rd power. Okay, both the numerator and the denominator. So the 5 is being raised to the 3rd power, and the x is being raised to the 3rd power. The y is also being raised to the 3rd power. Now, if this was multiple choice, you likely wouldn't see the 5 to the 3rd power, so you'd have to simplify it further. You're not asked to do so here, but if I did raise 5 to the 3rd power, just to kind of review, you would put 5 caret symbol 3 in your calculator, and you'd get 125. Okay, turning to the last page of this lesson. So why can't the product rule be used to simplify 2 to the 4th power times 8 to the 2nd power? So why can't I simplify this expression? Well, the answer is because the bases are not the same. I cannot add those exponents if the bases are not the same. But what we're going to do is we're going to be able to change some of the bases in order to simplify it further by applying what we've just been doing. For example, I look at my two factors here, 3 squared and 27 squared. Well, 3 is the smaller base, so I want to ask myself, how can I change 27 to have a base of 3? So in other words, 3 to the what power equals 27? Well, you can use a little bit of guess and check here. So if using your calculator, you could try 3 to the 2nd power, 3 to the 3rd power, 3 to the 4th power, and so forth. And in this case, it would be 3 to the 3rd power is the same as 27. But we can't forget about the 2 on the outside, right? So really what I'm doing is I'm substituting the 27 with the 3 to the 3rd power. Well, I have a power to a power, so I'm going to multiply 3 times 2, which is 6. And now I can simplify. Because I have two bases that are the same, I add 2 and 6 to get 8. On the right side, I can't simplify this right now because 16 and 4 are not the same base. Well, 4 is the smaller base, so I want to turn 16 into a smaller base, excuse me. So again, I'm also going to allow you to use guess and check on your calculator. If I do ask this on the assessment, it's going to be pretty quick, either to the 2nd power or to the 3rd power. I'm not going to keep you guessing for the entire time allotted to take the test. So 4 to the 2nd power is equal to 16, right? 4 times 4. So I'm going to take that 16 and I'm going to change it to 4 squared. But I can't forget that the 16 was raised to the 2nd power, so 4 to the 2nd power has to be raised to the 2nd power. Don't forget about the other 4 to the 5th. Before I even simplify this by the product rule, I have to raise the power to a power, so 2 times 2 is 4. And now my last step, I'm just going to add 4 and 5 together. Now, just a reminder, okay, you guys should have calculators, so you can always see if you did this correctly by just plugging your answer, by evaluating your answer and evaluating your initial expression, right? So if I type in 16 squared times 4 to the 5th, it should equal 4 to the 9th power. If it does not, we know we did something wrong. So my recommendation is try the exit question on your own. If this is something that you get wrong after you pause and then watch me do it, I would definitely shoot me a message on Schoology or send me a remind or email. So simplify the expression 25 to the 3rd times 5 to the 2nd. I can't simplify it right now because the bases are not the same. So I look at my smaller base, which is 5, and I tell myself I need to change that 25 into a 5. So 5 to the what power is 25? That would be 5 squared. Excuse me. I want to put the 2 on the inside, so let's just rewrite that, guys. But I also can't forget about the 3 that's being, the 3 as the exponent. I'm going to bring down my other 5 squared. And before I simplify this, well, going back to the first part of today's lesson, the power rule, 2 times 3 is 6. Now that my bases are the same, The product rule tells me to add these to get 5 to the 8th. Again, if I wanted to, I can always check if I did this correctly by doing 25 to the 3rd power times 5 to the 2nd power. That gives me 390,625. All right, I'm doing this live, guys, so now I want to see if I did this correctly. If I type in 5 to the 8th power, I also get 390,625. They're equivalent, so I know I did it correctly. So just to recap the 6 rules that you should know for this unit, okay, we've had 4 lessons, and we've had 6, I guess you want to call them laws or rules. In lesson 2, we talked about the product rule, and the quotient rule. So let me give you an example of both, right? The product rule, if I have something like 8 to the 3rd power times 8 to the 2nd power, since the bases are the same, I'm going to add the exponents. Whereas the quotient rule, if I have something like 10 to the 5th over 10 to the 2nd, since the bases are the same, I'm going to subtract the exponents. In lesson 3, we talked about the 0 exponent rule, or law. Did I say lesson 2? I meant lesson 3. And the negative exponent law or rule. So the key thing to remember with the 0 power is anything to the 0 power equals 1. Whereas something like the negative exponent rule, if I have something like 100 to the negative 2nd power, I would turn that to be a positive exponent by putting the 100 in the denominator. Last 2 rules is what we covered today. We have power of a power and power of a product. So again, giving an example, if I have something like 2 to the 3rd to the 4th, I'm going to multiply the 3 and the 4 together. I multiply the exponents 3 times 4. The only difference with the last rule, power of a product rule, or law, sometimes you'll see, is that we're going to have multiple bases inside parentheses. So for example, if I just change this to 2a to the 3rd power to the 4th power. So not only do I have a base of 2, but I also have a base of a. So 2 is being raised to the 4th power, but a is also being raised to the 4th power. So 3 times 4. Notice how in exercise or in rule 5, it was just 3 times 4 for 2, whereas in rule 6, 3 times 4 is just for a. Okay. Again, message me with any questions. I know this is a challenging transition, but you guys are doing excellent. I am very pleased with how the volume unit went, and so far it looks like you guys are doing great with the exponent rules. All right. Less than 2 months left of school. We can do it. Take care, guys.